Tēnā koutou, tēnā koutou, tēnā koutou katoa, ngā mihi nui, kia koutou katoa. If you've just joined us, welcome again to our Engineering Futures evening event for parents, whānau and teachers. My name is Colin and I'm a senior lecturer within the Department of Civil and Environmental Engineering.
And I'm Kelly Blinko, a senior lecturer in the Department of Electrical, Computer and Software Engineering.
And tonight we're also going to be joined by Jane Hay, who's one of our student academic advisors, and Mike Willamott, who is the Student Engagement and Development Manager. So we'll be hearing from them a little later. Just to give you a bit of an outline of what we'll be talking about tonight. So first of all, we'll be talking about why prospective students should choose the Faculty of Engineering at the University of Auckland. Kelly and I will briefly talk about our degree structure, and I'll give a bit of information about the first year. We'll then hand over to Jane to talk more specifically about some of the entry requirements, and then Mike will talk about the range of support options available for our students and some of the development opportunities that we offer. We'll also talk a bit about some of the really exciting career opportunities for graduates from the University of Auckland Faculty of Engineering.
Now, just to kick off, we'll give some very good stats about the Faculty of Engineering at the University of Auckland. So according to QS rankings, our faculty is ranked #1 in New Zealand, a #1 university in New Zealand. We also have a global reputation. And we're also ranked #1 in New Zealand for employability. We are top ranked for 4 of our specializations in New Zealand. So that's chemical, electrical, civil and structural, and mechanical engineering. We also have a diverse student body. This is a really important goal for our faculty to ensure that we have a diverse student body. And we have several key initiatives to continue to increase the diversity of our student body. The diversity is super important because of representation of thought in engineering. I like to give a trivial example. When YouTube was first launched, 13% of videos were being uploaded upside down. You might ask why, and it's because left-handed people hold their phone differently when they're recording videos. And this was something that the team didn't think of, and a great example of why it's really good to have diversity of thought on engineering teams.
So moving now to our degree, the Bachelor of Engineering is a 4-year honours degree, and it's taught entirely on our city campus. So Kelly and I are joining you live and direct from the new engineering building. We're in one of our lecture theatres there, and this building has some lecture theatres, but it also has a lot of really exciting multidisciplinary learning spaces that allow us to engage you with a much more active delivery of learning. It allows you to engage in practical projects, a lot of design and build work, and it's going to be really great to open those spaces up to students from next year. So looking to the first year of the degree, at the University of Auckland we teach in a semester system, so we have a first and second semester in the year, and the courses that you see listed on the slide here, the 3 on the left are taught in the first semester, the 2 in the middle can be taken in either semester, 1 in each semester, and the 3 on the right will be taught in the second semester. Giving a bit of detail about those quickly, EngSci 111 is a mathematical modelling paper. Now, as the name suggests, it is a mathematics course, but here the emphasis is really on taking mathematics, turning it into a model that is able to solve problems and tell you something about the real world. EngGen 140, Energy and Society, this is a course based on the subjects of biology and chemistry. These are very important subjects for engineers, but it's really putting those subjects in the broader context of energy and society. And along the way, we put a lot of effort into teaching students what it means to be a professional engineer. EngGen 121, Engineering Mechanics, follows on from the mechanics modules that students will study in their physics papers at high school. The general engineering education paper, which can be taken in either the first or the second semester, is a broadening experience that the university requires of all of our students, and it really gives an opportunity for students to take a course not specifically related to the engineering or science discipline that they're studying, but allows them to really broaden their horizons. EngGen 115, the Principles of Engineering Design. Like the Energy and Society paper, this paper has a lot of information about what it means to be a professional engineer. However, it also introduces one of the fundamental differences between engineers and, say, scientists, which is design. Engineers have to design products and systems that have never existed before, and they have to learn about the design process. They have to learn how to break really complex problems down into their component parts. And this is also a good chance to introduce people to working in teams. The material science paper doesn't assume any prior knowledge about materials science, but it really introduces a lot of the materials that students will use in the rest of their engineering studies and then beyond. The electrical and digital systems paper is a continuation of some of the electrical physics modules that students will have studied at high school. And the engineering, computation and software development course is really acknowledging the fact that whatever discipline of engineering students enter as graduates into industry, the ability to write code, to understand software and computation, that's really essential whatever stripe of work you end up in. So that's a quick summary of the first year of our degree.
Thanks, Colin. At the end of the first year, the students will specialize and they'll start to go deeper into knowledge in their chosen specialization throughout the remaining 3 years of their degree. This chart shows the places available for each of our 10 specializations for this year, 2020. So the students will choose their specialization by ranking their top choices. And we do our best to assign them to the specializations that they'd like to get into. This is done by considering the grade point average over the first year of the degree. So if your student has a specialization that they really want to get into, encourage them to do really well academically in their first year so that they have the best chance of getting their preference. You might wonder why structural has TBC next to it, and that's because that's one of our new degree. So we're still working out the numbers for that one.
One of the themes that you'll hear a lot tonight is that an engineering career is really, really exciting, but an engineering qualification from the University of Auckland actually opens up a whole range of careers, not only within traditional engineering disciplines. One of the real opportunities for our students who wish to explore some of these other career paths is to take a conjoint degree where they can combine their engineering degree with something from one of the other faculties of the university. You can see a number of different options listed here, but one of the really key advantages of an engineering degree when combined with these other degrees is that engineering really teaches people to solve complex problems, to work in interdisciplinary teams, to solve real-world challenges that might have a number of conflicting stakeholder requirements. And that really gives our graduates a lot of transferable skills, and when you combine them with one of these other qualifications, there's really no limit to what our graduates are able to achieve.
Another really integral part of our degree program is practically applying your skills to real-world projects. And we do this through a variety of ways. Students are required to do 800 hours of practical work, and this is typically done through internships. We also have Systems Week, which is a whole week in the second semester, the last semester of your degree, where we cancel all courses and you work together across all engineering specializations on a real-world complex problem, interdisciplinary in nature, working with diverse groups across all areas of engineering. We also have Part 4 projects, which is a 2-semester final year project that you work on pairs on real-world projects, and some of these are sponsored by industry. Even some of our courses integrate projects from industry. So we have industry partners come and give guest lectures or even participate in some of the projects in our courses. And now we're going to hand over to Jane Hay, one of our student academic advisors, who's going to talk a bit about entry requirements.
Thank you, Kelly. Kia ora koutou katoa. My name is Jane Hay, and I'm a student academic advisor in the Faculty of Engineering Student Centre. So first we'll start off with the recommended subjects to study during high school. So physics and mathematics are the backbone of engineering. So we recommend that for teachers and career advisors, you tell your students to take physics and mathematics all the way through. If your school does not offer calculus as a subject, then mathematics should be taken. And further along, I'll discuss the exact requirements for physics and calculus. So from 2016, the University of Auckland introduced the Academic English Language Requirement, or AELR, for all students, all new students doing a bachelor's degree. So the aim of the AELR is to ensure that students have a sufficient level of competence in academic English to support your study at university. So this requirement may be met through your entry qualification or through completion of an approved course in the first 12 months of study. For students, please be reassured that if you don't meet the requirement through your entry qualification, it does not affect whether you are offered a place on a program. You'll just need to pass an approved course, and this course will also fulfill your general education requirement, so you won't have to take any additional courses. The Academic English Language Requirement courses are specifically designed to give you the necessary skills to become familiar with the language of university so you can communicate effectively in all your courses. So the next few slides deal with the entry requirements for the Bachelor of Engineering honours degree. So for students who are doing NCEA, you'll need to attain university entrance and also a minimum of 16 external credits at level 3 in physics and 17 in calculus. You'll also need to attain a rank score of 260. This is for guaranteed entry into the Bachelor of Engineering honours single degree, or a rank score of 275, which is a guaranteed entry requirement for conjoint degrees. Now, I should say that when we talk about guaranteed entry requirements, all students who meet these requirements will be offered a place. But if students, for any students that don't meet the requirements, we say still submit an application, and if there are spaces available, your application will be considered. This is for NCEA, IB, and CIE. We also want to let you know that we are aware that the COVID-19 lockdown will have an impact on student study and will be taken into consideration for new applicants. The faculty at the moment is still deciding exactly what this will look like for NCEA, IB, and CIE students, and a decision around this will be made a little later in the year. Okay, so now this is the guaranteed entry requirements for CIE. So students will need to attain university entrance and also maths and physics to A level. However, AS maths and physics may be accepted based on the level of grade achieved. So for guaranteed entry into the Bachelor of Engineering honours, you'll also need to attain a score of 310. For guaranteed entry into a conjoint, you'll need to attain a score of 330. For IB, students will need to attain a full IB diploma and also maths and physics to higher level. However, SL maths and physics may be accepted based on the level of grade achieved. For guaranteed entry, you'll also need to attain a score of 33 for the single BE Honours degree, and for a conjoint, the guaranteed entry score required is 36. However, if you don't get into engineering via your year 13 results, there is another opportunity to apply into engineering, and therefore we've created what we call the alternative pathway via science. So students will do 1 semester in the Bachelor of Science and take 4 courses, including a maths and a physics course. If you complete your courses to the required standard, you will be considered for entry into the BE Hons in semester 2. It's important to note that a minimum of 30 places are available for entry in semester 2 after 1 semester of study in the BSc. Candidates will be ranked according to the grade point average, so it's important to do really well even from your first semester of study. So we have a number of resources available through our website that would be of interest to teachers and careers advisors. So STEM Online is a free interactive online teaching and learning resource and can be used as part of your curriculum for revision or homework. You can also find information about the Women in Engineering tutorials, school outreach program, and downloadable posters. So to find this information, just go to the community engagement section on the website.
Great. Thanks very much, Jane. We'd now like to hand it over to Michael Willamott, who's our Student Development and Engagement Manager, to talk about some of the support and some of the opportunities available for our students.
Student development and support. So we have two major goals, I guess, as a faculty. One is that for any new student who comes into our faculty, we want to make sure that they're well supported here and have the best chance of success. Now, our secondary goal is that while they're here, they have as many opportunities as possible to become the best possible graduate that they can be. So to do this, the faculty has a group of dedicated staff, and we invest quite heavily in this area, to supporting and improving the student experience. And these include things like pastoral support, career support, leadership development, and many other opportunities for students to actually be involved in the running of the faculties. And these exist alongside a lot of the opportunities that the university provides centrally. I'm losing my words. Centrally. So things like the counselling service, and there's a leadership program at university level as well. I'm going to go through some of the student clubs, and these are really at the heart of our student experience, an opportunity for students to trial leadership skills and meet like-minded people. They receive funding from the faculty and are really closely supported by dedicated staff. But if you're looking at it and you think, maybe these clubs don't look quite like you or like your student, or yeah, I say student, I'm used to pitching this at students, like your child or student that you're teaching if you're a teacher. There are a lot of other clubs and opportunities here. And the main thing that we have is that we want to find students to, give them a chance to be themselves and explore the thing that they're passionate about. So we recently sponsored our robotics association to go and compete in the BattleBots competition. And we're always looking out for interesting ways that students can, be involved here. And yeah, that's the last point. So everything we do is either led in close partnership or led directly by students. So these are all little opportunities for students to be involved. Okay, so I want to start with our Part 1 Assistance Centre, and anyone who has been to some of our other Engineering Futures presentations or just observed from Colin's slide, we have quite a tightly prescribed first year. One of the advantages of this is it means that every other undergraduate student in the faculty has completed these papers in the past. And one thing that we can do to support all of our new students is we can employ the high achieving Part 2 to 4 students to be drop-in tutors every afternoon for our Part 1 students. All right, Kelly's spoken a little bit about diversity in engineering and why it's important, and I second those words pretty hugely. There are a couple of parts to our Women in Engineering work that we do here. One is the Women in Engineering Network. So this is student-led and in really close collaboration with our permanent Women in Engineering advisor. The whole thing, students are funded directly from industry. There's a lot that goes on. It's a lot of social support and professional mentoring opportunities for students. The other part that we offer is a support program for students directly. So we have 2 dedicated staff that students can approach at any time. And while we're making really, really good progress, 28.5% I think of our student body is female, and that translates into about 280 something students in Part 1 being identifying as women. We're still committed to continuing to grow that into the future. So we keep it in the forefront of our minds always. And if you're interested in looking at more about what's available to students in school right now, what's available for teachers and what's available for current students, just head to womeninengineering.auckland.ac.nz and we have more information there. All right, so SPIES is another pretty special group to us. SPIES stands for South Pacific Indigenous Engineering Students and is primarily based around our Māori and Pacific students. Again, there is a dedicated staff member that works in close collaboration with senior students to deliver this to students. It also is closely connected with our MAP test program. Yeah, our MAP test program is a really important entry program to help continuing to diversify our student body. And currently our Māori and Pacific graduates are off doing some really, really amazing things. Students who enter through the MAP test program receive an extra set of tutorials that's funded directly from government and have a dedicated staff member to work alongside. And I guess just reiterating the point that Jane made before, if your student or you're not sure if they meet the guaranteed entry standard, that really is for guaranteed entry. We do consider applications below that if places are available. So if in doubt, apply anyway, and we'll look at every application carefully. The Dean's Leadership Program is another program that the Student Development and Engagement team offer, and is one of those extra opportunities for students to become a better graduate. It's largely based around looking at leadership as a curriculum that you can break down and learn about, and engaging with other industry leaders to see how they go about applying it. And the last part is around our employability. So students in our faculty have a very, very high employability rate, and I think Colin will probably speak to some of the stats in this section a little bit later. We have a lot of commercial interest in our students, such that we actually employ a full-time employer liaison manager to manage that relationship with industry. And to do this, we actually have a series of presentations that happen during semester where employers come in and talk to students about what they offer. At the same time, we do a lot of work with students to make opportunities available for them to learn how to be really good at interviewing, really attractive propositions for employers to approach. And this ties in really closely with our practical work hours, and these are offered very in close collaboration with industry. So they understand our need and use those internships as a point where they are involved directly in student learning. Awesome, and I'll hand back to Colin and Kelly, but I'll be here a little bit later to answer questions if you have anything in that space as well.
Great, thanks, Mike. Now we're going to talk a little bit about the exciting careers that your students can have coming out of an engineering degree from the University of Auckland, and really they're limitless.
So Mike mentioned some of the stats. Our most recent graduate destination survey conducted in 2019 found that 99% of our graduates were able to find graduate employment. So that's a statistic that we're really proud of. More generally, of course, our degree is accredited by the Washington Accord, and that allows our graduates, there are a number of signatory countries to the Washington Accord. Our graduates can travel to any of those countries, and they're able to work in that country as if they had graduated from an accredited degree within that country. So that grants our graduates with incredible mobility within the engineering profession. However, one of the things that you'll find, particularly as we talk to some of our graduate profiles in just a moment, is that the transferable skills that our students pick up during our degree mean that, as Kelly said, there really are no limits to what they're able to do. The skills that engineering graduates possess are in demand by a real range of industries, not only within engineering, and so there are no limits to where our graduates can go.
That's very true. So on Monday night, we hosted a night where we had a few of our graduates here, and one of them was from computer systems engineering, and she talked about how now she's working in the software industry. And one was from software engineering, and he talked about how he's an entrepreneur and has started his own business. So our students really can go on to do whatever it is that they want to do. We're going to showcase two of our graduates tonight, but it was difficult to choose because we have so many amazing graduates. So we'll start off talking about Emily Badley. And Emily is a graduate from our Chemical and Materials Engineering program. She started out, her first position, she was a graduate environmental engineer. So she went and worked at WSP Opus as an environmental engineer, which may seem a little bit far from chemical and materials, but she was able to draw on her materials engineering background in that position. Now she's working as a project manager at RCP New Zealand. And so she's really had a variety of jobs already coming from her chemical and materials background.
Another of our graduates is Michael Rasmussen, and he graduated from a mechatronics degree. He's now an electronics engineer at Motorsport Electronics and has what a lot of people might consider to be a dream job, working as technical manager at the Australian GT Championship. The great thing about Michael's story is he didn't have to wait until he graduated to get into racing cars, but he participated in our Formula SAE team while he was still studying. Now, if you want to join us for one of our other Engineering Futures evenings and hear from some of our current students, you can find out a bit more about the Formula SAE team and some of the other clubs and opportunities that are available to our students on campus. But Michael has a fantastic career. He's proven that our graduates are very mobile internationally, and it's a really inspiring story.
And now we're just showing a few of the places where our graduates have landed jobs coming out of the Faculty of Engineering. So you'll see big names like Google and Microsoft, but you'll also see lots of local, like the Auckland Council, Tonkin and Taylor, Ernst & Young, Honeywell. So there's so many different companies that our engineering graduates end up with careers.
So just to quickly wrap up what we've covered in tonight's session, we've talked a bit about why choose the Faculty of Engineering at the University of Auckland. We've provided you with some information about our rankings and the real strength of the diversity of our student body. Kelly and I have talked a bit about the Bachelor of Engineering honours course structure. Jane has talked about entry requirements. Michael's talked about some of the support available for our students and some of the fantastic development opportunities that we give our students to really grow into the kind of person they want to become, and that they can then take that forward into some really exciting career opportunities as graduates.
And we have a variety of on-demand videos on YouTube. So if you want to learn more about our faculty, about the university, about all of our programs, feel free to go and look at these on-demand videos. We also have some upcoming events. So we have an open day, and this just in, the in-person open day is going to be on the 29th of August. And we're also going to have an online open day for those of you that can't join us in person. And that's going to be on the 25th of August in the evening. So details will be coming out about those events shortly. We also have Ingenuity Day, and this is a day where we invite our local women high school students to come and experience engineering hands-on. And so details about both of these events will be out shortly. And now it's time to open it up to your questions. Remember, just you can use the Q&A button at the bottom, and we'll start going through some of the questions.
Okay, so the first question here is, what percentage of Part 1 students go into Part 2 engineering? And I think we'll hand over to Mike for this one because he spoke briefly to this at the start of his talk.
Yeah, it changes a little bit year to year, is the honest answer. If I'm recalling retention stats that move on, it's in the 90% range most years. So yeah, about 10% of students will choose to either not continue for whatever reason, or move to another qualification, which is what research tells us is about the right amount. But yeah, with the support that's available, and particularly that Part 1 Assistance Centre, that really gives students another way to connect with their learning and to connect with other people that have done it before. We have very solid pass rates within engineering.
Thanks, Mike. The next question is for Jane. Jane, if you don't have calculus, would I have to do another course in order to get into engineering?
Thanks, Kelly. That is a very good question. Now, if you're a domestic student, what we have to offer at the university is something called the Tertiary Foundation Certificate, or TFC. So this is for students who maybe have left school early or didn't attain the rank score to get into university, or didn't take the subjects they needed to all the way in high school. So the Tertiary Foundation Certificate is a whole year, and there is a specific pathway for students who want to be considered for engineering. So the engineering pathway prepares students to enter Part 1, which is the first year of the Bachelor of Engineering honours. And to complete this pathway, you've got to pass the Physics and Maths for Science course and achieve an A- for those courses, and also achieve an A- across all of the courses in the TFC. And every year we have students coming into the Bachelor of Engineering honours from the Tertiary Foundation Certificate.
Thanks, Jane. And now I'll ask the next question to Colin. Colin, is the FSAE Club a racing team? Do they go out to the tracks to race, or do they just design the SAE class cars?
So that's a fantastic question. I'm probably not the best person to answer this as I haven't been involved. However, I do know a little bit about the Formula SAE, and the answer is really everything. So the team design an electric vehicle from scratch. they're involved in the fabrication, they're involved in the testing, and then they get to race it and compete in a competition. So it's really the entire scope of the racing experience that they offer within that club.
Great, thanks, Colin. The next question is about the grade point average that you would need to get in part 1 to get into your preferred specialization, or to get into part 2 engineering in general. All of our students get into part 2 engineering if they've passed their courses and they want to get into part 2 engineering. We have lots and lots of support available for our part 1 students. So those students that are enjoying engineering and want to stay in engineering, they stay in engineering.
So the next question relates to mechatronics, and they're asking, what's the entry requirement? What subjects in high school should be taken? And for that one, we'll let Jane speak to the entry requirements.
Thanks, Colin. So I can answer this question, and I can also answer the question about what subjects should be taken if you would like to major in software engineering. So to get into the first year of the Bachelor of Engineering Honours, or Part 1, students need to have taken maths and physics in high school, or calculus if it's offered. Any other subjects you might like to take in high school is fine to do, but the only requirements to get into engineering, the first year of engineering, is that background in mathematics and physics. So once you get into the first year of engineering, all students, as Colin and Kelly mentioned before, will take the same 7 Part 1 first year engineering courses and a general education course. And all of those courses will equip students to go on to any of the 10 different specializations in Part 2.
Thanks, Jane.
So the next question I'm going to direct at Kelly, because it really relates to her area of expertise, and that's what subjects should be taken if you would like to major in software engineering?
Right, so the same response that Jane said, and that the entry requirements to get into engineering are general across all of our specializations. In fact, I am a software engineer and knew nothing about anything about software before I did my engineering degree. And a lot of our students are like that. So in your first year, you take a course where you learn about software development. So there's no special requirements for the software engineering degree.
Great. Thanks, Kelly. The next question I think I'll direct to Jane as well, and that's, why is the NCEA rank score needed for the BE Hons so much higher than for a BSc?
That is a very good question. Thanks, Colin. So the rank score, in fact, I believe the scores for CIE and IB are higher for the Bachelor of Engineering Honours than for the Bachelor of Science, is that for the Bachelor of Engineering Honours, a higher level of subject matter knowledge is required. And we want to make sure that students who come into the first year of engineering will do well. And so we know that having those, the rank scores higher will help students to come into the first year of engineering and feel confident that they'll be able to do well in the program.
Thanks, Jane. And somebody else online has also said, thank you, Jane. The next question is also for you. Can you talk a bit about the scholarships available for students?
Thank you, Kelly. Yes, I can talk about some of the scholarships that are available to students. Now, there are a number of scholarships that are available for students coming straight from school and students in the first year of engineering. The best thing to do would be to go onto the scholarships website at the University of Auckland and search for, you can search for all sorts of different scholarships. Now, the main ones for the first year students are the Kickstart scholarships, and there are 22 different Kickstart scholarships for engineering students. So if you have a look on the University of Auckland scholarships website, you'll be able to search for all sorts of different scholarships.
Thanks, Jane. And the next question I'll ask to Colin. What would you suggest for a student doing a conjoint degree with the Bachelor of Science?
I guess my main answer to that, this could be interpreted in several different ways, but in terms of what I would suggest, my main suggestion would be to do something that you're really passionate about. There's a lot of options between engineering and science where you can explore something where the two might complement each other. But more importantly, I think it gives you an opportunity to explore subjects that you're really interested in within both faculties. So as with many things in terms of career decisions, I think following something that you really enjoy is a great way to make those decisions.
Very true. All right, the next question is for Jane. Jane, could you do your bridging course as well as doing the engineering degree at the same time?
Thanks, Kelly. That is a very good question. Generally, no, unfortunately, students can't do bridging courses at the same time as doing their engineering degree. That is because we believe that we want students to do the best that they can when they come to engineering, and to complete the bridging course before you come into engineering will give students the best chance of doing really well right from the start of their degree.
Great, thanks very much, Jane. The next question I'm going to direct to Kelly. So the Ingenuity Day sounds like a fantastic opportunity. Is this open to Year 12 students as well as Year 13s?
Ingenuity Day is open to Year 13 students, but we do have lots of other options available for other high school students. Mike may want to jump in with some information on that.
Just exactly what Kelly said. Ingenuity is just focused on Year 13, but there will be an opportunity we will offer it next year as well. So if you're Year 12 right now, you can definitely come back next year. Open Day's coming up, but if you have a look on womeninengineering.auckland.ac.nz, there's a variety of other opportunities available for high school students at Year 12 and other levels as well.
Thanks, Mike. So you can go onto our Women in Engineering website to find out more details. Our next question is for Jane. Is a BCom and Bachelor of Engineering conjoint a popular conjoint choice?
Thanks, Kelly. That's a very good question. In fact, this year, the BCom, which is the Bachelor of Commerce or Business degree, and the Bachelor of Engineering conjoint is the most popular conjoint choice. Students, I think, from just about every different specialisation in engineering have done conjoints with business. And I've seen quite a lot of students who combine an engineering specialisation with finance or accounting, but students can combine a great number of different specialisations or subjects in engineering and commerce. The next most popular conjoint choice is the Bachelor of Science and the Bachelor of Engineering conjoint. And we see a lot of students taking subjects like maths and physics and computer science with an engineering specialisation. So there's definitely a lot of flexibility with a conjoint degree.
Great, thanks very much, Jane. The next question is also for you, which is how long does the bridging course take?
Thanks, Colin. That's a very good question. So the bridging course that I mentioned before, the Tertiary Foundation Certificate, it's 1 year in duration or 2 semesters.
Thanks, Jane. The next question we're going to pass to Mike. The question is, what kind of issues or struggles do first-year students face? And Mike can tell you a lot about the support that the university provides and the Faculty of Engineering provides for first-year students.
Yeah, I wish I could generalize. I think every year the challenges for first-year students change. But in general, the pace of delivery is quite fast and initially changing to a different type of delivery where you're expected to have a lot more responsibility for your own learning. And that's really something that we try and cultivate, especially as students begin to get more senior. So yeah, I think one of the biggest things that has come through at least my work with students is, the discipline to approach a subject, the ability to go and seek support when they don't understand a particular part of it, and they're going to encounter some subject material that isn't taught at all in high school. So in their very first lecture, they'll start looking at statics, which isn't really something that is taught at all within physics. And yeah, generally they're looking at dynamics, where something's expected to move or keep moving, not move, which is kind of the point of statics. And I think what I'll say about that is that there's a really, really wonderful teaching team in part one. There's a bit of competition, I think, internally within the faculty to get onto a part one teaching team. So the first person they run into is Professor Jason Ingham, who's our head of civil and environmental engineering. And he's taught that course for something like 20 years and really, really passionate about it. So they'll encounter material they don't know, but they'll also receive a lot of support to engage with it and understand it properly. And then alongside that, we realize kind of life happens. And for a lot of people, this will be their first time living away from home. There'll be different friend groups. There'll be, maybe something that comes along and it's difficult to make an assessment deadline or something. We have a pastoral support advisor that students can come and see if they run into these things and are not quite sure how to solve them themselves. So there's quite a lot for students in terms of those issues and how to resolve them.
Great, thanks very much, Mike. The next question is, what internship opportunities are available for students? And Kelly and I will start this, and if Mike and Jane want to chip in with anything themselves, we'll then pass to them. So Kelly, in your experience, what are some of the internship opportunities that are out there?
For the software students, they all have internships so quickly. There are so many jobs available for software students, and typically they turn those internships into full-time jobs, and they even continue to work in their third and fourth years at the university in their internships that they gained in their second and third years. So I see students working, some of them go overseas, some of them go, I had a student last year go to Microsoft in the US, I had a student go to Atlassian in Australia. A lot of them stay local and they work at some of the software companies here in Auckland. What about you, Colin?
So our students have a very similar experience. A lot of them are able to find internships with local engineering firms. That could be one of the engineering contractors, maybe one of the big consultancies, even some local government bodies. And a lot of those companies have really fantastic internship programs, and a lot of the students actually have a graduate job signed and sealed at the start of their third, or certainly by the start of their fourth year. The companies that hire these interns know when they've got a good thing, and they're really keen to snap our students up. So there's a lot of opportunities, and they often lead to continued part-time employment during the semester, as long as the student can balance that with their workload. But certainly the ability to turn that into a graduate position is really strong. So Mike, I'm not sure whether you had anything that you wanted to add about opportunities?
Yeah, ditto. We find the students that are really engaged in seeking an internship and engaging with multiple employers as just a course of their study throughout the qualification are often balancing sort of multiple job opportunities at the end. And because engineering is a real in-demand skill at the moment, companies really do want to recruit and then retain the students that they've invested in interning with them. So yeah, I think, as I said, a lot of commercial interest in graduates from our faculty at the moment, so much so I have to pay someone else to try and manage it for me. But yeah, there's a lot of, if the students have some guidance as well on how to navigate them, I think our employability rates are very, very strong at the moment.
Great, thanks, Mike. The next question is a really good two-part question, and Kelly and I will start to speak to that. So first of all, what qualities are really important for engineers? And secondly, is problem solving something that can be learned, or is it more of an innate ability?
Thanks, Colin. I'll start with the first part of the question about what qualities are really important for engineers. We recently did a survey of the software industry asking them what they looked for when they were hiring software engineers. And of all the skills that we listed, many software skills, teamwork, being able to work in groups, communication, ethics and integrity. All of these were things that people were looking for when hiring our engineers. Fifth on the list was producing high quality software. So the basic idea of being able to work in groups and work together and communicate is really, really important for engineers. Going to the problem solving, that's not an innate skill that you need to have to get into engineering. We teach the process of how to solve problems. We teach about analyzing the problem, considering all of the different solutions, and coming up with the best solution by really considering the needs of lots of different stakeholders. So this is something that we teach our students throughout their whole 4 years at the university. We really focus on design in all of our specializations. Colin, do you have anything to add?
No, just to echo the same thing, that within the civil and environmental engineering industry, they basically echo the same sentiments, where what's the number one skill that you're looking for in a graduate? It's communication. It's the ability to work in diverse groups, the ability to not only communicate with those around you, but to be able to communicate very specialist technical knowledge to stakeholders who may not have the same specialist technical background. They really want people who can think about budgets. They want people to act ethically, and it's really these overall professional skills that we weave throughout our degree that employers are looking for. Down the track, yes, they want really strong fundamental engineering technical skills, but those aren't normally the skills that they are first and most keenly looking for.
Great, thanks, Colin. The next question is for kids who are really interested in certain subjects like chemistry. Would you recommend taking conjoint programs like chemical engineering and sciences major in chemistry? Would that be kind of repetitive and taking only one degree a better choice? Thank you so much. And Jane will answer this one for us.
Thank you very much. That is a very good question. And in fact, we do have students who are doing a conjoint with a Bachelor of Engineering honours and a Bachelor of Science in Chemical and Materials Engineering and Chemistry. You'd think there'd be a lot of overlap, but there really isn't. If there was, then we wouldn't let students take those two combinations. So Chemical and Materials Engineering has more of a focus on materials engineering, and the students will also be learning about applied chemistry, materials characterization, process engineering, energy, and mathematical modeling. So even though there is some similarity, it's enough of a difference so that it would definitely be worthwhile if you had a student or a child who was really interested in chemistry and chemical engineering, to do both of them at the same time. And I'll also answer another question I see here from Ruth, who is asking about conjoint. And she's asking, as engineering requires relatively long internship hours in third and fourth year, would choice like taking summer school to finish conjoint programs faster affect students' internship opportunities? No, it wouldn't affect the students' internship opportunities, because students will often take, well, they've got to take an extra year at the end of their conjoint degree to finish usually the other side of their conjoint. So if you are doing a Bachelor of Science and a Bachelor of Engineering conjoint, that final year would be usually taken up with completing the science side of your degree. We have a lot of conjoint students who do manage to do an internship in summer school and complete their conjoint within the 5-year time frame. So it's definitely doable.
Thanks, Jane. Mike, the next question is for you. Are there learning support for those who have learning difficulties, example, dyslexia?
Very short answer, because I know we're down to the last 5 minutes. The short answer to that is yes. It's particularly helpful if you already have a diagnosis for that learning disability. We have an academic, a student support advisor. Sorry, I'm mixing up Jane's job title with staff in my team, that can help the student go through that process. They need to register with the Disabilities Office, and if they're entitled to additional time or other accommodations to make sure that they're on a fair playing ground with other students, we can put them in place ahead of any assessments.
Great, thanks very much, Mike. The next question is for Jane, and that's, when is the deadline to apply for engineering?
Thank you, Colin. That's a very good question. So we suggest for students interested in engineering to apply as soon as possible. However, the deadline for semester 1 entry into the Bachelor of Engineering is the 7th of December. So as long as you submit your application before that date, then your application will be considered. And even if you do submit your application a little later, if there are spaces available, we can still consider it.
Thanks, Jane. And can you answer another question about specific courses that you'd recommend students to take to get into their preferred specializations, possibly aeronautical engineering?
Thank you, Kelly. That is a very good question. At the University of Auckland currently, we don't have aeronautical engineering as a dedicated specialisation. However, you may be interested in taking courses in engineering science and mechanical engineering.
Great, thanks very much, Jane. So that brings us to the end of our allotted time to answer your questions. We'd like to thank all of you for being such an engaged viewing group. We've really appreciated the opportunity to answer some of these questions. So we'd really like to thank you for tuning in, and we do hope to see you again soon.
Yep, and we hope that you encourage the student that you're associated with to apply to our program. And if you are a student watching, we hope that you apply to the program. Thanks again.
And good evening.